Solving other types of equations. There are many other types of equations in addition to the ones we have discussed so far. We will see more of them throughout the text. Here, we will discuss equations that are in quadratic form and rational equations that result in a quadratic. Solving equations in quadratic form. Equations in quadratic form are equations with three terms. The first term has a power other than 2. The middle term has an exponent that is 1/2 of the exponent of the leading term, and a third term is constant. We can solve equations in this form as if they were quadratic. A few examples of these equations include x to the 4th minus 5x squared plus 4 equals 0, x to the 6th plus 7x cubed minus 8 equals 0, and x to the 2/3 plus 4x to the 1/3 plus 2 equals 0. In each one, doubling the exponent of the middle term equals the exponent on the leading term. And we can solve these equations by substituting a variable for the middle term. If the exponent on the middle term is 1/2 of the exponent on the leading term, we have an equation in quadratic form, which we can solve as if it were quadratic. We substitute a variable for the middle term to solve equations in quadratic form. So let's just take a look at these three examples. Okay, we're just going to show how we start this off. So we have x to the 4th minus 5x squared plus 4, which is equal to 0. So we want to write this in quadratic form. Quadratic form means we have something raised to the second power minus this constant, which is 5, and the second term is raised to the first power plus the constant, which is 4. Okay? So what we do is we take this middle term. And this middle term that we have is x squared. Because x squared raised to the first power gives us x squared. Whatever we get here, we're going to write over here, which is x squared. So this x squared to the second power gives us x to the 4th. Let's look at the next one. We have x to the 6th plus 7x cubed minus 8, which is equal to 0. And again, we want to write this in quadratic form. So we have something raised to the second power plus, let's do that again, we have something raised to the second power plus 7 times something raised to the first power minus 8, which is equal to 0. So the middle term is what we're always going to put in the parentheses because x cubed is what we're going to put here, which means x cubed to the second power is x to the 6th. Let's take a look at the other one here. We have x to the 2/3 plus 4x to the 1/3 power plus 2, which is equal to 0. So again, we want to make sure that we have something raised to the second power plus 4 times something raised to the first power plus 2, which is equal to 0. Now again, we're going to take our middle variable term, which is x to the 1/3. Because x to the 1/3 raised to the first power is x to the 1/3. If we put an x to the 1/3 over here, x to the 1/3 squared is x to the 2/3. So therefore you can see what happens is how we substitute. And then we're going to do one more thing before we proceed. So the next step is, what we're going to do is we want to be able to then use a substitution. And what I mean by substitution is we're going to let u equal the x squared that we just found as our substitution. Same thing with this example. We're going to let u equal what we got for our middle term, which is x cubed. And then over here, likewise, we're going to let u equal x to the 1/3. Okay? And then the last thing that I'm going to show you on this is how we put it in quadratic form, which is the reason why we have an equation in quadratic form. Because now, instead of writing x squared, it's going to be u, and then we're going to square it because that's what we're squaring. Minus 5, we're putting in u to the first power, plus 4 equals 0. And then over here, step 4, we're going to let u equal x cubed, so we're going to get u squared plus 7u minus 8, which is equal to 0. And then over here, we got u, which is x to the 1/3, which is u, again it's squared, plus 4u plus 2, which is equal to 0.